This is lesson 37, VHDL example 21. You remember in the last example we made a 4-bit comparator by cascading 4 1-bit comparators together. In this example we're going to design an n-bit comparator, and we're going to use relational operators. As we'll see, this is a much easier way to design a comparator in VHDL. Here are the relational operators and logical operators in VHDL. Equal is a logical equality. Slash equal is logical inequality, not equal. Less than is less than. Less than or equal is written this way. Greater than or equal. And then not, and or are the logical negations, logical and logical or. So let's see how we can make an n-bit comparator using relational operators. We'll use a generic parameter n. You remember we've seen this before. In this case we'll set n as a default value to 8 using this : equal 8. But in general, when we get to the port map, will be a generic map statement where you can set it to anything you want. And then x will be an n-1 down to 0 input. Y is standard logic vector n-1 down to 0. And then greater than, equal, and less than are the 3 outputs. Well, here's how you do it. You have a process xy, and then you just set greater than, equal, or less than to 0 to begin with. Now this is important to do this because it's important that every time the process executes, that is any time x or y changes, we need to make sure that all 3 values get some value, either 0 or 1. So if we say if x is greater than 0, then greater than gets 1. Now remember, we set greater than to 0 here, but remember the signal assignment statement doesn't get executed until the end of the process. So even though we set greater than to 0 here, if x is greater than 0, then that greater than will become 1, and that will be the final value it gets. If x isn't greater than 1, else if x is equal to 1, then we'll set equal to 1, else if x is less than y, then we'll set less than to 1. So again, if x is greater than 1, only this statement gets executed, and the equal and less than don't get executed. So therefore it's important that equal and less than get assigned values here. So in any combinational circuit, you always want to initialize your values to some value, in this case 0. If you don't do this, then VHDL will assume you want it to stay the same, and it will actually infer a latch. We'll talk about latches later, but that's not what you want here. So it's very important that you make sure that greater than, equal, and less than always get assigned some value each time through this process. Well, you can simulate it. We did it here for an 8-bit value. We started with 15, incremented x by hex 16, or 10 here, and then we're comparing it to hex 75. When it's equal to 75, it's equal. If it's less than 7.5, less than will be 1, and if it's greater than 7.5, then greater than is 1. So in fact it works.